Okay, y'all, let's look at number 6. So number 6 is kind of flip of the one we just had. You know, we just did one with the rope pulling up, which meant that the normal got help, right? So when the rope was pulling up on the box, then there was an FG here, and the normal could be smaller because it was getting help from the F tension Y, right? So FG equaled F normal plus F tension Y. But now the same sort of thing is happening, only there's a pushing down, right? So you exert a constant 10 Newton force directed down, right? And there's the theta, and we just assume it's like that. And so what's true here is that there's a down force. We'll just say F push on box by person. And there's an FG on box by earth. And then the normal force, let's see, there appears to be a coefficient of friction, so there's going to be some friction like this way. But I'm just going to come over here and do this real quick. There's the force push, right? And the force push is going to have a force push Y and force push X. And let's see, so there's the theta. So here's something to watch out for. Look what I just did. So when I see this force push Y, the way I've drawn it, the Y, force push Y would be cosine. Do you see? Because it's adjacent. But it says that it's 37 degrees below the horizontal. So the theta that it's telling me is 37 is this one up here. Okay? So that means this theta is not 37. That's a right angle, and this would be 37. So I got two choices. I can just find the complementary angle and use it. And if you see how to do that, you can just go right ahead. If this is blowing your mind, then the way to see it, the best way to have done it would be to have paid attention to the words initially. And then to say, hey, there's my component there, right? F push X and F push Y, right? So now the X component is cosine and the Y component is sine. So I'm going to say F push Y equals F sine theta, which would be F push Y is going to equal 10 newtons sine 37 degrees, which would be 6 newtons. And then F push in the X direction is going to equal 10 newtons cosine 37. And that should be 8 newtons. All right, so it helps. It's sort of like getting out your ingredients before you cook. It really helps to go ahead and get those components. So now when I look at this, I see that I have FG, but I also see that I have this piece here. So these two have to be supported by force normal. So, if I call that 2, and I basically call that 2, then force normal is going to have to be, 1, 2, 3, 4. And if I do an equality statement in the Y, it's going to be the force normal has to support both the FG and the F push Y. Okay, if I do an equality in the in the x direction, then let's see what's happening now. You exert a constant force. Constant force causes a constant acceleration while pushing the thing. Level surface from rest. So if something starts from rest, right? I'm going to come over here and take a look at the graph now. So I'm going to say 10, 20, 30, 40, maybe 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Because if I start from rest and I travel along a level surface and they give me the coefficient of friction. Okay, so let's see equality in the x. In the x. Okay, so what do I know about things in the x? So F net is going to equal F push x minus F friction, right? So that's what's going to be F net there. So let's see what they're asking. They're asking for Fg. Well, the easiest way is mg, right? Can I just get it that easily? 1 kilogram, yeah, times 10 newtons per kilogram. That's pretty straightforward, equals 10 newtons. Okay, so we've got weight. The normal force we said was F normal equals Fg plus Fpy. Now something to point out is, like, you see how this kind of builds, right? I find the weight and then now I need to use the weight. The AP exam likes to do it that way. So they like to have you find something in part A and use it as you move through. So F normal then is going to be 10 newtons plus, what do we say Fpy was? Plus 6 newtons. So I think force normal is going to be 16 newtons. So I think that's good. All right, so boom. The frictional force, now remember, what did I tell you it was likely to do? It was likely to have you find something and use it. Okay, so let's see, mu force normal, yeah? So mu is 0.2, normal is 16, so force friction then should be what? About, let's see, sorry guys, this was originally done with 9.8, so let's just see. 0.2 times 16 is 3.2, okay? All right, so that gets us friction. And now, what's the acceleration? So to me, there are lots of ways to do it. I could use all those kinematics equations and stuff, but sum of F equals MA. I know that the sum of F, right, and the X, let's look and see. FPX, we did find to be 8 newtons. Force friction is 3.2 newtons. Sorry, that's bad. But again, I want to point out, they're having you use what you have found, right? So F net then equals what? 4.8, yeah? 4.8? That's fine, about 4.84, something like that. So 4 newtons, 4 newtons, or something like that, divided by 1 kilogram equals acceleration. So 4.8 meters per second squared. Okay, that's it. 1, 2, 3, 4. Boom.